This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at one of the most prominent sorting techniques, which is bubble sort. Let's have a look at what a sorting technique actually is. Sorting is nothing but arranging the data in either ascending or descending order. There are n number of sorting techniques you might have seen in your academics, like bubble sort, insertion sort, selection sort, quick, merge, heap, shell. Many are there, and the most prominent ones I have listed over here. And one of the easiest one is bubble sort. Easiest in the manner to understand. Basically, in the sense of understanding, I'm saying this, guys. Bubble sort is one of the easiest one, right? Let's have a look at the complexities, how it works on. So bubble sort, the best, average, and worst cases are different. The best case, order of n. If there are n elements in your list, then the complexity in the best case will be order of n. Coming to the average and worst case, it is very high, which is an exponent of n per n. We go of n square will be the n into n, as it runs with the loops. So that is the average and worst case. Yes. When can we say that bubble sort is running on its worst case scenario is when the number of elements which we need to sort are huge, are in a lot, right? So as the basic funda of bubble sort goes with comparing two consecutive elements in every iteration, right? So if there are n elements, it will run for n minus 1 iterations. So even the list is ordered, it will run. So the worst case, if the number of elements are higher, it becomes higher. And it is not going to use any extra space. So the space complexity is order of 1, which is very less when compared to the time complexities. It is a stable one and it is an in-place one. We are not going to take any temporary list, any intermediate list to store temporary data, nothing of that sort. Everything will be done by using just swap techniques, right? So let's have a look at the basic algorithm of bubble sort. So take the list which is unsorted. First of all, predefine your mind whether you want to get it in an ascending order or descending order. Usually we work on ascending orders, right? So first of all, the pointer will be pointing to the first element, that is the element at 0th index. If the current element is greater than its consecutive element or the next element, swap them. Continue this process. Compare elements with a 0 and 1 index. In the first iteration, I'm talking about index values. If we talk in terms of index values, compare the elements with index 0 and 1. If the element at index value 1 is smaller than the index value element at 0, then swap them. Then go for the next comparison between the elements values at the index values 1 and 2, then index values 3, 2 and 3, and so on. This will be go iterations unless you sort the whole list, right? This is the basic funda of bubble sort, which I'm going to explain you using an animation. Please have a look at this one. This is an unsorted list. I have taken a very small list which consists of just 5 elements: 21, 54, 36, 18, and 29. Initially, the first 2 elements are compared. I have highlighted, guys. Have a look. So as the first 2 elements are compared, it is going to check for, as I want the list to be in ascending order, it is going to go for a less than symbol for comparison purpose, right? It is going to check, is 21 less than 54? Condition is satisfied. So there will not be any swap. So let's go for comparison of the next 2 elements. If you go with the index values of this array, 0, 1, 2, 3, and 4 will be their index values. First, we have compared the elements at index values 0 and 1. Then we have going to compare the elements at index values 1 and 2, as I have said, right? So compare 54 and 36. Our operation, relational operator, which I'm going to use is less than. This condition fails as 54 is not less than 36. When it is not less than 36, swap the elements. So I have swapped the elements. So in the index value 1, now I have 36, and at index value 2, I have 54. So as per the funda, now it will be the comparison between the elements placed at index value 2 and 3, which is 54 and 18 respectively. And the relational operator which I'm going to check is less than, right? Is 54 less than 18? Condition fails. The relation fails. So swap them. So 18 and 54, they are in right order now. No comparison between the elements present in index value 3 and 4. The relation which I'm going to take is less than. It is fixed, guys. If you want to arrange the data in descending order, where the highest element will be placed in the first position, then just reverse the symbol. Make it as greater than. That is enough, right? So come back to our current scenario. I'm trying to check, is 54 less than 29? The condition fails. If the condition fails, swap the elements. I swapped the elements. Have a look at this one. Now, when I increment my pointers, so I say I and J are the controlling pointers. I and J both are being incremented. I will be pointing to the last element 54, whereas if I increment J, it will go out of box, right? It will be going on pointing to an element which is not a part and parcel of my list. So it tells that it is the end of the first iteration, right? Have a look at the list which I get by the end of the first iteration, guys. You can clearly see that 54, which is the largest element of your list, is at its right position. That is, it is placed at the highest index value, right? So this is the scenario of a basic point in your bubble sort. By the end of each iteration, the highest element in the list will be coming to the highest index value. So now onwards, I'm not going to touch 54. I'm going to freeze that value. So have a look at this list. So this is the starting list of my second iteration, which I have fetched from the end of the first iteration. You can see that it is frozen. 54 is frozen. So I have converted its color as blue, right? Just to specify that it is frozen, right? So now my loop is going to run from only these 4 elements, right? I have to check for the positions of only these 4 elements, whose index values are 0, 1, 2, and 3 respectively, right? Let's do the process. Consider 21 and 36. Check for the less than relation. Yes, 21 is less than 36. I need not do any swap. Now, comparison between 36 and 18. So, as 36 is less than 18, it's not less than 18, the condition fails. As the condition fails, I have to swap them. I swap it. You can see that I have swapped the elements, right? Now a comparison between 36 and 29. Is 36 less than 29? No, the condition fails. As the condition fails, I'm going to swap them. As I swap them, you can see that I have reached the end of the sublist which I have considered. You can see that I am not going to touch the last element, right? Because it is in its right position. Now, we come to end of second iteration. As we come to an end of second iteration, you can see that the second largest element, which is 36, is in its right position. Right? Is it have come to its right position. So I'll start my third iteration with the last step of second iteration, but I will run for only the leftover elements. Let's have a look at that one. See, I have converted the colors of the last two elements into blue just to specify that these two values are frozen and we are not going to touch. So I'm going to specify index values of only those elements in my list for which I need a swap, right? So let's compare between 21 and 18. Is 21 less than 18? No, the condition fails. As the condition fails, I'm going to swap them. Now a comparison between 21 and 29. Is 21 less than 29? Yes, the condition is satisfied. I need not swap them, right? So, and there ends the list. Have a look, guys. I'm going to consider only the first three elements because only these three elements I need to sort them. The remaining elements which are at higher index values are already sorted, right? So now I reach the end of this iteration, and you can see that the third largest element is at its right position, right? So I am left with only two elements. With these two elements, I'm going to start my fourth iteration. So their index values will be 0 and 1, right? So have a look at the three elements which are at end colored as blue, saying that they are frozen, right? So let's compare between 18 and 21. Is 18 less than 21? Yes, the condition satisfied. So you need not swap, right? So now you can see that we reach an end of the list and 21 is the fourth largest element in your list. Even that is frozen, right? So we can say that the final list is. So how many iterations we are going to go? If there are n elements in your list. N, this is the size of the list. Then n minus 1 number of iterations you are going to go for. So imagine this comparison, guys. What if just for 5 elements I have run for 4 iterations? What if you have 100 elements? What if the size of n is 100? You have, or 1000, right? You have to go for the number of iterations will be 999. You will not even know if the remaining elements are already sorted or not. We will be blindly going for that, right? That's why we call that bubble sort is a very simple technique, a very useful and effective one if you have very few, that is handful of elements to sort. If you have more number of elements to sort, then the complexity of this process raises drastically. So whenever you have very few elements in your hands, bubble sort will be used, and bubble sort can be used as an intermediate sorting technique. If there is a huge sorting technique which is messed up with many things, so a subset of elements can adopt bubble sort to sort themselves, right? So in that way, bubble sort is very helpful, but not for the whole list. If the conditions apply, if the size of the list is very high, right? So with this, I'm going to end the basic introduction of bubble sort and how it works. Now I'd like to show you a simple Python code for the same, right? Let's navigate, guys. Yes, guys. Now we are at the Python script area where I'm going to open Python script. This is Python shell, right? So Alt F, and I'm going to open a new script to write the bubble sort function, right? So let's see how to do this one with the Python. Guys, those who are familiar with the function concept and how to read a list, basics of Python, this is a quite very simple and easy task to handle, right? Let me maximize my screen first and let's start doing it. First of all, let me write the purpose of my task, that is implementation of bubble sort. First, always guys, please remember, mention the title of the program, what you are trying to do. You need not elaborate it, explain it briefly, but just with few words, you just tell them what this program meant for, right? Right. Let's start with basically the driver code, right? So what I'm expecting, right? That let me do that. First of all, I'm going to read the maximum size of elements, right? So how many elements I want to sort? Int of input, right? Enter the number of elements, right? So enter the number of elements is the first statement. Now, I'm going to take a list. I'm going to read that list. So the basic function to read a list is with the help of a map function, right? Let me use the same map of so I'm going to split them. This is the function to read a basic list. But as I have read the size of the list as limited to n values, I just want to use a splitting operator so that I'll slice the list. So as many numbers as you read, but I'm going to take only the first n values, right? So I'm going to use a slicing operator there, that is called an n, right? Next, to sort, I need to call that function, right? So bubble. Guys, always give relevant names to your function, right? So looking at the name of the function, one must be able to say or able to understand what this function is going to do. Even a novice must be able to understand that. Okay, and the only parameter that I'm going to pass to bubble sort is the name of the list, which is ARR. Okay, fine. Once I complete this function, once I come out of this function call, I just want to print the list, the sorted list, the final sorted list. So with this simple statement, I'm going to close my driver code. In the driver code, I have simply taken the maximum number of elements that I'm going to read, right? Then I have read n number of values and placed them in a list with the name ARR. Then I'm going for a function call. Let me mention with the user-friendly comment line function call, right? So with this function call, I can you can understand that we have to write the body of the function, which we have not done yet, right? So let me take some space and let me write the function. Yes, this is the starting line. That is or I can say this is my function definition. Function definition. Okay, bubble sort function definition, which is going to take just the array as or the list as its basic input, right? So let's go with the logic. What we have to do, we have to compare two consecutive elements, right? And how many iterations we need? N minus 1 iterations, where n is the number of elements in your list. So you need n minus 1 iterations, right? For that, I'm going to write the loop for I in range of. So if I take length of array as the delimiter, then the job is done, right? If the length will be the last one, that will be the stopping point. I hope you know how a for loop runs. For loop basically have the mandate parameter is the stopping criteria, where it is supposed to stop. By default, if you do not give any parameter, it will start with the value 0. So here in my for loop also, it is going to start with 0 and it will end with n. What does that mean? It is going to run for 0 to n minus 1 number of times. Right? Fine. Then I need to run each and every loop. By the end, guys, remember one thing. By the end of each iteration, one element is going to, or the highest element in the list which I'm going to consider is going to come to its right position. That means the number of comparisons are going to reduce one by one till my last iteration. So to specify the same, I'm going to say this is my stopping criteria, guys. N minus I minus 1. So it is going to, my range function shows two parameters. One is the starting 0 and the stopping is n minus I minus 1. Even if you don't give 0 or there, by default it will take 0. Just for one, for the outer loop, I have not taken the starting point. For the inner loop, I have taken, just to show you the difference, basic difference. There is no much difference. If you give, it will take it. If you do not give, by default, it will take the value 0, right? So let's go inside. Let's have a comparison between the elements. If the element pointed by j is greater than the element pointed by j plus 1 index. If this is the scenario, if the element pointed by j is greater than the element pointed by j plus 1, right? Swap them, right? So it is very simple to swap the elements in Python. So just mention their index values, right, is equal to error j plus 1 comma ARR of j. Just simply by using this statement, you can swap. Just like a is equal a comma b, or I can simply give you an example, is equal to b comma. It is as simple as that. If you give a comma b is equal to b comma a, the content in a and b will get swapped, right? So here I am going to swap the content in j and j plus 1 locations. Okay, so this is a process. So basically the ith loop or the outer loop is going to run. Outer loop is going to run for each and every iteration. Within iteration, comparisons will be done by this inner loop. Outer loop will be handled by the variable I, whereas the inner loop is handled by the variable j. Let's have a brief overview of what we have done. So let's check for syntax errors, if any. Okay, then I have read the value of n, the list of elements, then a function call, and I'm going to print the final list, right? So coming to the function definition, I've taken a loop, outer loop, to have a hold on the number of iterations, and inner loop to get a hold on number of swappings, and this is a condition to check, right? And this is the swapping, right? Swapping statement, right? I think the job is done. Let me save this one. So I'll store it with the relevant name, which is bubble sort. Let me compile this in. Yes, it is asking me for the number of elements. Let me give a small list. I'll say that 5 elements, and the elements are 4, 3, 5, 2, 6. Randomly I have given, guys, I have put my fingers and that's it. And this is the list which you got. 2, 3, 4, 5, 6, and the list is sorted. Right? So, guys, I hope you have seen this. And again, I'll bring you back to the program. Right? So, have a look at this one. This is a bubble sort function or a script which demonstrate bubble sort, is simple one, the basic one, which is very helpful if you work with a limited number of elements. Please do follow my videos, guys. In the coming videos, I'll show you how insertion and selection sorting techniques will be handled. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.